We're live?
Yeah.
All right, we're in the home stretch, segment 3. Here we go. Transformations. Know your parent functions, know how to move them around. This is just a simple absolute value function. These things go off at 45 degrees like that in the parent function form. We want to take this and we want to reflect it over the y-axis. So we want to flip it down like this. Okay. So that's going to be a minus sign out in front. Minus x. And I guess I will, yeah, like that. So that's going to flip it that way. But then we want to translate it 3 units to the right. We want to move it this way. So remember, it's opposite land. So minus 3 goes right there. That will give us, when we plug in a 3, will give us 0, and will give us that belly button point. And then down 1 is when I do a minus 1 out there, because that is not opposite land. All right, and then I'm going to compress it by 1/2 in the y direction. So to smoosh it this way, that 1/2 comes out front. I'm going to cheat a little bit, make the 1/2 there, and make that minus sign. Okay, so you can check. This is where having a calculator doesn't hurt, because you can always type it in and make sure you've done that. Okay, so this is a little bit of an application of the last unit and brought into this transformation unit. You should know that your basic graph of a sine function starts at 0 and does this swoopy thing like this, and it does it in 2 pi. You want to label the start and the finish. And I guess the middle doesn't hurt, but I probably won't take off, because 2 points will determine your scale, and that's fine. It goes up to 1, and it goes down to -1, okay? But now what's happening with this? All right? So this is the horizontal adjustment. So I'm taking and I'm moving it plus, because it's the opposite. So this is really going to be not 0, but pi over 4. That 0 is shifted as much as it needs to, and this is plus pi over 4. And you can just leave it like that, because that's accurate. If you want to make that 8 pi over 4 and add 1, it would equal 9 pi over 4. Okay, that's a 9. Then this is the amplitude. It's being stretched, so those 1s become 10s. I'll maybe just go back to the blue marker. That becomes a 10, and that becomes a -10. But then the whole thing is moved up 2. So my 10 then becomes a 12, and my -10 becomes -8, and I'm good. I've done all 3 of those things. I've shifted it, I've moved it up, and I've stretched it 10 units. Okay? So here we go. We're given, in this case, a triangle, ABC. Graph that thing. Try to sneak it in right here. If I go over 1 and up 4, we'll say I'm right, well, maybe not that high. Right there is about 1, 4. I go over 3 and up 4 like that. And then I go over 3 and I go up 7. So I've got a triangle that looks kind of like this. Okay? What happens to the new translated or transformed triangle, A prime, B prime, C prime, if I'm multiplying it by this simple matrix? Okay, so this, you want to know how to do matrix multiplication, but it's pretty easy. When I flip this like this and smack it upside right there, I'd have -1 and 0. It's going to ignore all of these because it's 0 and just change each of these to negative. So it's going to become -1, -3, -3. And then when I do this and switch it and flip it up there, it's going to become 0 and 2. So it's going to ignore the top row and double the bottom row. 8, 8, and 14. Okay, so if I go to graph that, do that purple here, I would go -1 and then all the way up to 8. And I would go -3 and up to 8. But then I go -3 and I go way up to 14. All right? So what's happened to this? Oops, -8 up to 14. I did it backwards because it's not -1, it's -3. So the right angle is there. Sorry. That's what happens when you're working live. So it flips it over the y-axis and it stretches it by a factor of 2. So what happens? Flips, or reflects is the better word, over y-axis, and then vertical stretch. Don't say dilation, by a factor of 2, okay? what matrix will reflect it over the y equals x line? Hopefully you've studied this a little bit and you've learned that the thing that will switch the x and the y is when we go 0, 1, 1, 0. Check and see. What you want to do is you want to take the top row and move it down, take the bottom row and move it up. That swaps the x and y, that will reflect it over that line. Okay, on to the last thing, final unit on the unit circle and angles. Sketch these angles in radians, okay? So what I'd love for you to do is just think about each of these in terms of like a little mini unit circle, all right? So pi over 4, just remember the benchmarks. This is 0, all the way around is 2 pi. If you can remember that, you can remember certainly that that's pi. This is pi over 2, so pi over 4 is right there. So that's your angle. You can just sketch it like that, okay? Sketch 11 pi over 6. Same type of thing. You go like this, and you've got 0 and 2 pi. Well, if you go by 6, there's 1, 2, 3, 6, 4, 5, 6. 6 is halfway around the circle, or 1 full pi. Right over here, right there, is 11 pi. 11 pi over 6, okay? And then 2 is more just your ability to figure out if this is a radius of 1, you go 1 radius, you're about there, 2 radii, you're about there. So that's approximately 2 radians. Okay, there's no pi in that, so don't think you're going all the way around. You mostly want to pay attention to, is there a pi symbol? That'll be a nice fraction. If there's no pi symbol, just remember that it's about 6.28 radians all the way around. Convert the above into degrees. Okay, well you're going to multiply. If you want to go from radians, pi over 4 radians, you just want to multiply by the number 1 in the form of 180 degrees over pi, because this is equal to itself. All right? So the pi's cancel. 180 divided by 4 is 45 degrees. Okay, 11 pi over 6, do the same thing. You get 330 degrees. And then 2, when you multiply that, the number 2 times 180 degrees over pi, you just need to get the calculator and say it's approximately something, which we'll have an answer for in a second, okay? Give the exact values based on your knowledge of the unit circle. Very quickly, you guys took a little quiz on this. 3 pi over 4, that's right here. The sign is just radical 2 over 2. The sign is the y, so it's positive. If this had been cosine, it would have been the same thing, but with a negative. 114 degrees, 0.6. 114.6 degrees is the approximate answer, okay? The tangent of pi over 3, okay? Again, where is pi over 3? Well, that's 1/3 of the way to pi, so that's about right there. 1/3, 2/3, 3/3 the way to pi. This is the short amount for the cosine, and it's the long amount for the sine. This is equal to sine over cosine, so it's radical 3 over 2, all over the short amount, 1 over 2. The 2's cancel, and you just get radical 3, okay? And finally, the cosine of 3 pi over 2. Don't be fooled by this because you're counting by half pi, 2 halves of a pi, 3 halves of a pi. The cosine there is just 0, okay? Finally, in the home stretch, if some angle is in the 3rd quadrant, okay, so we're talking about an angle that's somewhere down here, okay, somewhere down here in this 3rd quadrant, and we know the sine is whatever 8 pi over 3 is. Well, you can put that in your calculator. It's going to be close to 1. So this angle is going way down here like this, okay, because the sine value is nearly 1. Sketch the angle, which I did. I'm going to get a little bit better, darker marker here. So it's going to be around like that, approximately. Again, how do you know it's there? Because I can take that number and put it into my calculator. It's very close to 8 over 9 square rooted, so it's about 0.9 something. So I know that the sine value is how far down we go. So I go with this value like this, I draw over, and it's going to hit about there. Sketch the angle, then find the cosine of that. Well, the main thing you want to know is that the sine squared of theta plus the cosine squared of theta is equal to 1. And we know everything but the cosine then, because I can square this value. And then when I square it, I get 8 over 9 plus, I don't know what the cosine squared is, but I know that 1 squared is 1. So when I subtract this from both sides, I get the cosine squared of theta is equal to 1/9. And then all I have to do is take the square root of both sides, and I get the cosine of theta is equal to, well, what's the square root of 1/9? It's exactly 1/3. So this happens to be an angle where the cosine, I would go over to about 1/3, and then I would go straight down, and I'd be at that angle. So what's the tangent? That's equal to the sine of theta over the cosine. Well, I already have both of those, so I just plug them in. The sine is radical 8 over 3. The cosine is 1 over 3. I can cancel the 3's, and I get radical 8 over 1. So it's just plain old radical 8. So it looks hard, but it isn't that hard when you know it. Good luck, everybody.